5136, runway 3 to left, clear for takeoff.
Clear for takeoff, aircraft 5136. Clear for takeoff, Mike.
Just 4 months apart, 2 deadly crashes of Boeing's new 737 MAX jets took place that were initiated by a malfunctioning sensor. Both scenarios left pilots in a deadly struggle against a new flight system, which ultimately forced their jet into a nosedive.
The Boeing 737 MAX is the 4th generation of the Boeing 737 narrow-body airliner manufactured by Boeing. It succeeds the highly popular Boeing 737X generation and competes with the Airbus A320neo. The 737 MAX is based on earlier 737 designs, which led to drastic engine mounting position changes. Boeing engineers repositioned the new larger engines slightly forward, which caused a lift effect that forces the plane's nose in an upward direction that causes a stall. In accordance with that, Boeing engineers implemented a new software, the Moving Characteristics Augmentation System, in short MCAS, that essentially prevents the nose from reaching a stall and forces the plane's nose downwards. Let's review what the MCAS does. It pushes the nose of the plane down when the system thinks the plane might exceed its angle of attack limits. It does so to avoid an aerodynamic stall. Boeing put MCAS into the 737 MAX because the larger engines and their placement make a stall more likely in the 737 MAX than in previous models. When MCAS senses that the angle of attack is too high, it commands the aircraft's trim system to lower the nose. It also does something else, indirectly, by something Boeing calls the elevator field computer. It pushes the pilot's control columns downward. Here are the possible root causes regards to MCAS. The larger 737 MAX engines could not be fit beneath the wing and was brought forward that caused a lift effect, forcing the nose up, causing a stall. The 737 MAX had an unstable airframe. Next, the instability was masked via MCAS. The software relied on systems known for tendencies to fail, like the angle of attack sensors, and did not implement provisions to cross-check the outputs for the angle of attack sensors against other sensors, like flight instruments and etc. This is our solution for MCAS.
In the first system, the desired AOA is fed into the autopilot system, which is then controlled by the MCAS. MCAS rectifies and attempts to match the AOA input, which then adjusts the elevator and stabilizers. The AOA sensor then rectifies the AOA and feeds it back to the MCAS to ensure the preferred AOA is achieved and making minor adjustments if required, preventing the likelihood of a stall. In the second system, say however the aircraft's nose pitches downwards, the second half of the system is activated, whereby full manual control is given to the pilots. As the pilot adjusts the flight yoke, it updates the flight ailerons, which feeds into the flight instruments and back to the pilot, and repeats this cycle, producing the actual AOA.
Therefore, it is strongly recommended for Boeing to implement a software cross-check system indicator, just to how human pilots would. Meaning to say, if one angle of attack sensor indicates the plane is about to stall, and the other sensor says otherwise, hold off the judgment on pushing the aircraft's nose to the ground, and instead alert the pilots regarding the conflicting nor misleading signals.
Question 2 given is suppose we are at a remote site and then we will have to survive on our own for at least a week before the rescue team is able to reach and dispatch us to safety. It is said that the site is surrounded by forest but close to a stream. We have identified some of the key issues for survival, which is source of water, food supply, shelter, and predators. The easiest shelter to make when we are in a remote area is a lean-to out of branches and leaves. Find a long, fairly straight branch and lean one against the tree. Cover the whole thing with large leaf to make a cover. Predator. We can hide in our shelter. It is made from leaves, and camouflage helps us hide from the predators. Since we are next to the stream, we can obtain water. Next is the food supply. Our dining when we are in a remote area, the choices largely revolve around edible plants, fruits, insects, and fish. Since we don't have any guidebook on edible plant varieties, we will need to figure it out on our own. It can be deadly to eat a plant we are unsure of, so it's better to try and find food elsewhere than to risk eating a toxic plant. Since we are living next to the stream, we could build some fishing equipment with the primitive ways. This can help us catch fish to fill our empty stomach. Next, effect on degree of doneness. Undercooked contain bacteria like Salmonella, E. coli, and Listeria. Can get food poisoning from eating meat that hasn't been cooked. Seafood that aren't well cooked can spread infection called vibrosis. Overcooked, burn. A chemical called acrylamide is found to be present in burnt or charred food. It's found more in starchy products like bread and potatoes. Besides the presence of carcinogens, which is cancer-causing agents, in burnt food adds to the danger.
To avoid getting disease through consuming various bacteria and viruses, we have to reduce the pathogens in the food as much as we can. This is where the temperature control takes place. By controlling the temperature and raising it, it allows us to reduce and kill as much of the harmful pathogens in the food as we can. The temperature where the food must not be consumed due to the high risk it holds is known as the temperature danger zone, which ranges between 4 degrees Celsius and 60 degrees Celsius. While on the other hand, food should always be cooked at a temperature range between 60 degrees Celsius and 74 degrees Celsius to make sure all the germs and pathogens it holds are reduced and killed. That is why a control system to control the temperature at which the food is cooked is designed, where the desired temperature goes through the semi-injection and then passes through a timer that controls how long will it take to cook the food. Then a heating element is also added to provide the necessary heat needed. Finally, the food is added to the system and then is cooked. A temperature sensor is also added to make sure that the desired temperature is met successfully. The semi-injection will make sure to subtract the actual temperature from the desired temperature, which is then finally pushed to the timer and then proceeds through the rest of the system.
Let's say an airdrop is possible, and the instrument we need for the control system that we created previously are timer to measure the time needed to reach the desired temperature, and also our heating element, we need a fire, so we need a match, a lighter to create a campfire. Since we're stranded in a forest, we can create the campfire from dry wood. And also we need a thermometer to measure the temperature in our food. So how does it work? How does this control system work? How do we actually control the temperature when we cook our food? Since we know that food should always be cooked between 74 Celsius and 60 Celsius to kill off the bacteria and to avoid any food poisoning, let's imagine we have a graph where the x-axis is time and the y-axis is temperature in Celsius, which is the temperature in our food. Let's set our desired temperature at 65 Celsius, which is the temperature in the middle of the range that was previously mentioned. If we measure our food and we obtain a 10 degrees Celsius, we will have an error, a very large gap of error, as you can see, which is desired temperature minus the actual temperature. So as long as the error is not zero, we will have to keep repeating the process until we reach our desired temperature. So when the temperature obtained from the thermostat is equal to what we desired, it means that the error is equal to zero. So when the error is equal to zero, we can call this process as completed, as we have achieved what we wanted, as we have achieved the desired temperature as intended. So we can turn off the timer and extinguish the fire, and we can enjoy our food without any poisonous, without it being undercooked or overcooked. So that is all from us today. Thank you.